இம்மிடியேட்டா நம்ம நெக்ஸ்ட் ஸ்பீக்கருக்கு போயிடலாம். அபிநந்தன். அபிநந்தன் வந்து ரியலி அ ஸ்மார்ட் கிட். அபிநந்தன் காலேஜ்ல இருக்கும்போதுன்னு எனக்கு அபிநந்தனை தெரியும். நம்ம கோயம்புத்தூர் கம்யூனிட்டியில முதல்ல இருந்தே இருந்தாரு. அப்பவே நிறைய கேகல் காம்படிஷன்ஸ் எல்லாம் பண்ணிட்டு இருப்பாரு. நல்ல வண்டர்ஃபுல் பிளாக்ஸ் எல்லாம் எழுதுவாரு. அப்புறம் அவர் வந்து ஒரு அனலிட்டிக்ஸ் கம்பெனி பெங்களூர்ல வந்து ஒரு 3 இயர்ஸ் ஒர்க் பண்ணிட்டு இப்போ ஃபுல்லாமே வந்து தமிழ் ரீசர்ச்ல வந்து தமிழ் எல்எல்எம் ரீசர்ச்ல வந்து அவர் ஃபோக்கஸ் பண்ணிட்டு இருக்காரு. இண்டிக் எல்எல்எம்ஸ்ல ரீசர்ச் பண்ணிட்டு இருக்காரு. அவருடைய தமிழ் லாமா இட்ஸ் லைக் ஒரு பேன் இண்டியா லெவல் பெஞ்ச்மார்க் மாடலா இருக்கு தமிழுக்கு. ஏன்னா நீங்க மற்ற மாடல், இந்தி மாடல், தெலுங்கு மாடல், கன்னடா மாடல் கம்பேர் பண்ணும்போது அவங்க வந்து ஒரு குளோபல் ஸ்டாண்டர்ட் யூஸ் பண்றாங்க. தமிழுக்கு வந்து நம்ம அபிநந்தனோட மாடல் தான் வந்து இப்போதைக்கு ஸ்டேட் ஆஃப் ஆர்ட். லாமா ஃபைன் டியூன் பண்ணியிருக்கிறாரு, ஜெம்மா ஃபைன் டியூன் பண்ணியிருக்கிறாரு. அவர் வந்து அவருடைய தமிழ் லாமா மாடல் பில்டிங் எக்ஸ்பீரியன்ஸ் பத்தி நம்மளுக்கு இப்போ எக்ஸ்பிளைன் பண்ண போறாரு. ஸோ அபிநந்தன், வெல்கம். தேங்க்ஸ் ஃபார் அக்செப்டிங். த ஸ்டேஜ் இஸ் யுவர்ஸ்.
தேங்க்யூ. தேங்க்ஸ் நவனீத். நான் இந்த கம்யூனிட்டியில் ரொம்ப வருஷமா இருக்கேன். நவனீத் ஆல்ரெடி சொன்னாரு. ஸோ ஒண்டர்ஃபுல் ஒர்க் பண்ணிட்டு இருக்கோம் ரொம்ப வருஷமா. ஐ ஹோப் இது நம்ம பிளான் பண்ணதை எல்லாமே அச்சீவ் பண்ண இட் வில் பி மேசிவ் பிகாஸ் one thing that I see lacking in Indian community developer communities that open source research work is not happening at the pace that we see in other countries like China and USA. So I think this is going to be a massive initiative. So yeah, let's get started. Let me share my screen. I'm unable to share my screen. No.
அபிநந்தன் ஒரே நிமிஷம் இருக்கா? ஓகே.
Okay, I think it works now. So I'll take this session in English because of the technical nature of this. It will not be very technical, but it obviously helps if you know a bit of NLP. So this is in this session I will be covering how Tamil LLaMa was developed and the motivations behind why it was developed and the challenges that I faced, and probably also discuss about some of the limitations so that as a community we can work towards enhancing the existing LLMs moving forward. So I'll be mostly drawing from my own experiences and also some of the other work that has happened in the field. Feel free to post me questions at the end of the session. So before getting into the details of about Tamil LLaMa, let's just have a brief look at what it is and what is actually available. So Tamil LLaMa is just like the other language models that have become popular these days, but unlike those other models, Tamil LLaMa can converse in Tamil to a pretty good extent. So here I've given an example. So where we start with the greeting, Vanakkam, and then it says, hello, how are you? Vanakkam. And then I'm giving it a technical task. For it to be able to do this, it has to I understand the language that I'm speaking in, because some of these terms even I didn't know before creating this instruction. So yeah, so the task is basically to upload a local file to an AWS S3 bucket, and the model is able to output a code that actually works. It looks pretty good, and then further when we query about what Boto 3 is, and it responds back with a reasonable response about what Boto 3 as a library does. So these kind of chatbots were majorly missing for Indian languages. So I started working on Tamil LLaMa back in August and September. At that time, Llama 2 was pretty new. I was thinking about this earlier in the Llama 1 days, but when Llama 2 came out, I thought of giving it a try, and luckily worked out. So yeah, there is also a paper that I published. This was just this just started as an experiment that just exploded because of the results that I was able to get from these experiments. And there is a detailed research paper if you would like to have a look, and you can read this to get into all the technical details about what was actually done. And there is also a code base. It's open source. It's available on GitHub, so you can refer that to adapt LLMs for other languages or improve Tamil LLaMA. And the models are also freely available on Hugging Face, and more than 50,000 people have already downloaded these models. So I guess some of you might already be aware of Tamil LLaMA. But a lot of questions that I receive is how did you do it, and what are the steps involved and all that, which I will be addressing in this session. So before moving into how Tamil LLaMA was developed, let's focus on the current landscape of large language models. So if you see this graph shows us from the earlier days of when we had Glove and Word2Vec to more recent ones like GPT-4 and even Llama. If you pay close attention to it, some of these branches have evolved into uh, more specialized areas. Like some of these out here, Libert and all that, those are encoder only transformers, and some of these over here, like T5, or encoder decoder transformers, and the more popular ones like GPT-4 and Llama, those are decoder only models, which are generally more popular for uh, conversational uh, tasks or causal language modeling at very large scales. So these LLM, most of the LLMs out there today are decoder only transformers, and the field has seen a tremendous rise in the number of LLMs that have come out. Mainly after ChatGPT, this graph might be a little incomplete, but there are dozens and dozens of other models like Mistral and Quen. A lot of models are out there. So, and the reason why I chose Llama was because at that time Llama was the best open source LLM. Right now it's not. There are a lot of other options out there. So we'll discuss that in a pretty detailed way. So let's get on to the other slide then. Yeah. Also, the one more other thing to notice, the ones that are shaded in the dark are open source, and the ones that are not open source. Uh, After 2022, there were a lot of open source LLMs as well as there were a lot of closed source LLMs. And these closed source LLMs have made uh, great strides, and they've popularized LLMs in a way that we have never seen before, like ChatGPT. And before going to Tamil LLaMA, I would like to discuss about the Indic LLM landscape today. I think, Tamil LLaMA was developed in was launched in November 2023. At that time, when I launched Tamil LLaMA, there was no other Indic LLM uh, for any Indian languages. But fast forward to today, not even 3, 4 months into the future, we have a thriving community of a lot of great people working on LLMs for languages like uh, Hindi, Tamil, Telugu, Kannada, Odia. There's a lot of work that's going on in this space currently. And most of these developments that have happened recently follow a similar approach. So I hope this session is going to be enlightening for a lot of you, because uh, if you're going to make improvements on these on this approach, then basically you also have the scope of expanding this to all the other Indic LLMs out there as well. So there's a lot of scope for research in this area right now. And these languages that we see today are spoken by millions of people around the world and also in India. So that's most of these LLMs also share the foundational model, which is Llama 2. More recently, I saw an ODM model come out of Quen, but almost 95% of the models that I've seen are based on Llama 2. There is a reason for it. You might ask why not Mistral, but we'll get on to that later. And before moving into we are talking about a lot of LLMs and all that, but what they actually do, how are they trained? If you look at that information, LLMs are basically next word predictors, which are trained on large amounts of internet data, uh, almost the entire scale of the internet. Like Llama 2 was trained on 10 terabytes of data and 2 trillion tokens. Tokens are nothing but smaller representation of a language like words and subwords. So 2 trillion is a lot of tokens, and this is probably going to be impossible for the human race as a whole to to be able to read all that information and learn from it. But these LLMs are uh, pretty good at predicting the next word when trained on these huge amounts of data, which enables them to excel in tasks like text generation and even assistive style chatbots, like we saw a couple of slides back, and a lot more other use cases as well, like text classification, a lot more other use cases that most of you guys will already be familiar with. But the main problem is the internet is filled with English data. On the left, we are seeing the real world linguistic demographics of all the languages in the spoken in the real world, uh, where Chinese is spoken by more than 1.2 billion people. That's a lot more than Spanish, English, French, and all of that combined. So, but still, if you look at the internet representation for Chinese, it's very, very small. As you can see from the graph right here, it's only about 1.8% of the internet, whereas English is contains 53% of the internet as English. This data might be old, but still the same differences can be observed even today. And for languages like Tamil, there is hardly any representation at all if we compare the scales right here. And that's part of the reason why LLMs struggle with low resource languages. The reason why we call these languages low resources is because there's not a lot of data available on the internet. And to train a foundational model, you need a decent amount of data, and they have to be pretty evenly distributed to see any good performance. But yeah, if you look at Llama's training distribution, that tells you a completely uh, different story. Like the same story basically, where almost 90% of the data that was used to train Llama was English, and 8.4% is unknown here. This comes directly from the paper, but that 8.4% is believed to be code from GitHub and other sources, and around I don't know how much this is, but it could be close to 4 or 5%. That could be for other European languages like French, German, and Russian and all that. And the rest of the that's nothing like 0.4% of the data was for the rest of the language of the world combined. So because of this stark difference in the data that was used to train this model, these not just Llama, most of the LLMs out there struggle with low resource languages because of this reason. And let's just see if popular LLMs can generate text in Tamil, starting with Llama 2 70B. It's not 7B, it's 70B. So when I say Vanakkam, it's able to understand that Vanakkam, what that means, but it's not actually responding back in a way that we want in Tamil. It's just identifying that Vanakkam means hello. And then later when we go on to ask a question like how to fall asleep better, விரைவாக தூங்குவது எப்படி, uh, it just goes on to produce something that's not relevant, that's completely irrelevant to the context and doesn't make sense. So this problem is there in most of the open source LLMs. Most of the open source LLMs do not perform very well in Indian languages. If you look at ChatGPT, for example, it is able to respond back when we create it. And when we ask it a question, although it is able to produce a response, it's not coherent enough, and in some areas it doesn't make sense. So if you see Ungal Ruki Vanatil Kal, I don't know what that means, but still it's not able to form proper sentences. And GPT-4 is a lot better. In fact, the best LLM that's currently available for, I don't know, any language out there. So it excels in Tamil. It is able to give very good response in Tamil, not just Tamil, a lot of other Indian languages as well. But the scale of training something like GPT-4 is of course massive, and this model is suspected to have close to 1.5 trillion tokens, and it was trained on, nobody knows how much data it was trained on, and it probably costed millions in, I don't know, even $1 billion. So training a model of that scale is pretty hard. So, but if you see, most of the LLMs are not good. Actually, open source ones are terrible at Tamil. And although ChatGPT can respond to some instructions, it's not perfect. And it doesn't even form sentences properly. And that's the problem that I was trying to address when developing Tamil Llama. So, starting with the Llama models now, when we when I started, there was Llama 1. I was fine-tuning a lot of Llama 1 models on downstream tasks. And then Llama 2 came out, and that is when I saw an opportunity of fine-tuning, or even I didn't even know what I was going to do, but I knew I was going to adopt this Llama 2 for Tamil. At least I'm going to try. Because at that time, Llama 2 70B model came pretty close to ChatGPT, GPT 3.5 Turbo. I said close, not it didn't match or outperform ChatGPT, but still it came pretty close, which was pretty big deal at that time for open source community. So choosing Llama in September was a strategic decision, I believe, because that was the best LLM available at that time, and it was also possible to adapt it for other languages. This was first proven by Chinese, whose work I started as an inspiration with, and started Tamil Llama. And there are a few variants of the Llama models here, 7B, 13B, up to 70B models. 70B is the biggest of them all, and 7B is the smallest of them all. Even training a 7B model for an individual or a non-profit is not going to be an easy task, especially pre-training. We'll come to that later. But basically, Tamil Llama is available in two variants, 7 and 13B. The 70 is too big for me. It was too big for me to fine tune, so I didn't attempt that. Now let's look at how Llama was trained. Uh, there are a few stages that go into training LLMs, and this is where a lot of beginners have confusion with. Sometimes I've seen people downloading the base model and asking, and then trying to use it like for a chat task, and then complaining that it's not working. It's not working because it's not supposed to work because it was a pre-trained model. So pre-trained models are trained on large amounts of internet data, uh, like uh, like we saw before, and they are not actually fine-tuned for any interaction with humans. If you ask it, what's the capital of France, it'll probably give you more questions than answers, like uh, what's the capital of Germany and all that. But if you prompt it correctly, it might respond back with what you need, but still it's not meant for user interaction. So the first stage of pre-training is where we train on a large amounts of internet data. This is the most expensive stage of them all. And once you have a foundational model, the base model of foundational model, we can then fine tune it for chat or even other downstream use cases. I think supervised fine tuning is the most popular way to adapt these models for to make them follow instructions, and that's exactly what Llama 2 was also had also undergone. And there's an optional final stage in training LLMs called RLHF, reinforcement learning with human feedback. This is again pretty expensive if you consider the amount of work that goes in behind it. Uh, but recently there have been a lot of improvements in this area. We now have DPO, which is it's like a clever way to modify the loss function so that we don't have to uh, optimize our policy. So yeah, so that eliminates the need for reinforcement learning as well. So that was a massive advancement that has happened recently. And if you look at the amount of money that went behind training these LLMs, it's estimated that Meta spent over $20 million in training Llama 2, all the variants of Llama 2. And if you look at some of the GPU house right here, it's unimaginable for even small scale companies and individual researchers like me. So the other strategic decision comes here because by adapting existing foundational models for other languages, it's not going to cost a lot of money. It's going to cost a minuscule amounts of money, like $100 or $200. So yeah, and that's one of the other advantage of adapting. Finding pre-training a model, as I said, is expensive. I mean, by expensive, I mean it will take it cost you millions of dollars to do it. And the current challenges for adapting LLMs for Indian languages that there is not enough high quality data sets available. For pre-training, of course, most of the LLMs are trained on web scale data from the internet. So we have data for Tamil, about 4 billion tokens, I guess, from the Kalsurax dump. So I think there'll be a lot more data if we count for all the data on the internet, but all the available options that I saw was close to 5 billion uh, tokens of Tamil data. That's nothing when you compare it to the amount of data that when began training Llama, for example. Llama was trained on 2 trillion tokens. Uh, that's thousands of times more than what we are talking about. So order of magnitude higher. So the lack of high quality data sets, again, that's one of the other reasons why it makes sense to adapt existing LLMs to other languages than training a foundational LLM, because uh, there's a lot of technical challenges out there, starting from uh, data. And the existing vocabulary of these LLMs are very limited. That means uh, Tamil words in Llama, for example, is close to non-existent. That even when Llama doesn't have these words in its vocabulary, it can still respond in Tamil because of something called byte pair tokenizer, and it falls back to the byte representation, the Unicode byte representation. So basically, for every character, you might have uh, 3 different byte tokens. So that's going to slow down the generation and the learning ability of the model. So that's another challenge. It does work since these LLMs are already huge and already trained on a lot of data. It can also work without expanding the vocabulary, but uh, it's generally pretty slow to converge. And and there is also no evaluations of benchmarks available currently. All we have to rely on is comparing with other models like GPT 3.5 and asking human to rate, or asking GPT-4 to rate, since GPT-4 is pretty good at uh, Tamil and many other languages. That can also be used as an evaluator, but it's not perfect. So there are there's a huge opportunity in creating benchmarks for Indian languages currently, and that is something I've also discussed with in the AI Tamil Nadu community, and there'll be a lot of efforts coming up for this as well. But yeah, currently we don't have any benchmarks, and I've told you that it falls back to the byte pair tokenization. So if you look at something like GPT tokenizer for both GPT 3.5 Turbo and uh, yeah, for GPT 3.5 Turbo, for a simple sentence like the sky is blue, the same thing in Tamil is similar in terms of the number of characters required to represent the same information in 2 different languages. But if you look at the number of tokens that are needed by these LLMs to represent the same information, it's almost 5 times more. almost 5 times more here. It takes 5 tokens to represent this information. The sky is blue. Uh, but when you look at simple sentence, not even a sentence, a couple of words, it takes 25 tokens for uh, GPT to represent the same information. And that is a problem that we are going to tackle in Tamil LLaMA. And if you look at the Llama model, it's not there is not much difference. Although slightly smaller amount, slightly better, it's not nowhere near what is required to accurately represent a language. And here I'm presenting you the most popular way to adapt Llama for other languages. When I started in September, the other reference that I had was for Chinese. But there are differences between Chinese and Tamil, very drastic differences between Chinese and Tamil. So it was nothing more than a bet of trying to do this. But when I researched it, I thought it could work. But yeah, luckily it worked. And the most important stage was continued pre-training here. Because without that, that's where most of the performance and the language understanding comes from. Vocabulary expansion, as I said, since there are not many tokens in the vocabulary, we need to expand the tokenizer. And in order to expand the tokenizer, we need to train a new sentence-based model with something like close to Llama 2 configuration on a decent amount of Tamil data to get the new vocabulary. And then once you train the tokenizer model, we get the vocabulary and then append it with Llama's vocabulary and expand the embedding dimensions so that the new embeddings matched with the expanded vocabulary. And yeah, we also merge the tokenizer, modify the tokenizer to include the new vocabulary. There is also a change in the model in terms of expanding the embeddings. And then after expanding the embeddings, I moved on to directly pre-training it. There are a few ways, like freezing all the other parameters except the embeddings and training only those. But even that is not very cheap to do. So I moved on directly to pre-training, and I'm pretty glad that I did because uh, continued pre-training is very effective if you do it correctly. And yeah, this is where, as I said, most of the performance comes from, and a very crucial stage, and the most expensive one as well. And for instruction fine tuning, again, this is another area where there are no data available currently. I think at least at that time. So uh, I had to rely on translating existing data sets like Alpaca and OpenOrca to Tamil. And basically, how I did that was first write a rule-based algorithm to classify which ones to translate and which ones to not. And then the ones that you can translate can be easily translated, right? And then ones that cannot be translated, like code and English specific things like identifying grammatical errors and all those instructions, those are not specific to those are language specific, so it doesn't make sense to translate it. So identify those separately and then find a way to manually curate them or whatever way to get them ready for instruction fine tuning. So luckily, I didn't have to do a lot of manual work there, but I did do some work. But I don't think that is enough. So, after instruction fine tuning, the first I started with Alpaca dataset, which is a pretty popular dataset from Stanford University, and which I translated to Tamil. And I was pretty impressed with the performance after just Alpaca, but decided to expand it to a bigger dataset like OpenOrca and merge it with uh, Alpaca dataset. And then, of course, after doing that, the performance improved even better. And now we talked about expanding the tokenizer and all that. So we'll look at how that affects the representation of the language inside the model. So for Tamil text like this, Tamil உலகில் உள்ள முதன்மையான மொழிகளில் ஒன்றும் செம்மொழியும் ஆகும். Fairly small sentence, right? And it takes Llama 89 tokens to represent the same information. And for GPT 3.5, it takes about 89 tokens, which is coincidentally exactly the same as what it takes to represent information llama. And most of these are byte representations if you pay a close look. But the modified Tamil LLaMa tokenizer only needs 18 tokens to represent this information, which is just like 5 times better. So obviously, after expanding and pre-training, we should see pretty good results in Tamil. And this is one of the example conversation with the model. I've taken this directly from my paper. So here I'm prompting the model that I'm not a very rich guy, and should I be spending a lot of money in buying buying the new iPhone 15? And I'm asking that in Tamil, and the model gives back a response, which is pretty clever because it's asking you to analyze by yourself and come to a conclusion. But it doesn't just stop there. It's telling you the new iPhones might also bring better features as well. And depending on your financial goals and your budget, it's your job to uh, make a priority of whatever you need. And then this is not an expected outcome because it was not trained on a lot of coding samples. But since it was trained on, since it was adapted from Llama model has already seen a lot of code data in its training. So the interesting thing here is for the models to do this, it has to have a strong understanding of Tamil as well as uh, able to translate internally about the meaning of both the languages and to come up with a response like this. And the reason why the model doesn't use any Tamil here is because of the rule-based algorithm that I mentioned that says which parts to translate and which parts to not. And when trained on that data set, the model identifies the code has to be in whatever way that it has to be. So it gives a pretty small explanation about how this works as well. But when we prompt it with a detailed explanation of how Quicksort algorithm works, it might go into all the details. But here we're just asking it to implement it in Python. It does a pretty good job in doing that. Especially the 13B model, since it's bigger, is also better in many of these analytical and coding use cases. And if you look at reasoning tasks, uh, here I'm just prompting it that there are 4 apples on the table. One guy ate an apple and then another guy took away 2 apples. How many apples are left? It might look very simple for humans, but LLMs usually struggle with the verbal uh, things like this, verbal instructions like this, which are also required to have a pretty good reasoning or mathematical understanding to answer. So these verbal questions are commonly struggled by a lot of models, like 7B model gets it right in this case. Also, the 13B model gets it right in this case. But if you prompt it with more complex prompts, then it's probably going to fail because most of the LLMs struggle with reasoning tasks. But in this case, it's able to respond back in Tamil in a in a and then also give the correct answer. So, what are the alternative approaches that could be considered while trying to adapt an LLM like this for Tamil or any other language? The first thing is you can decide to ignore vocabulary expansion, but by doing that, the biggest problem of doing that is the training time will increase 4 or 5x because there are not a lot of tokens in your vocabulary, and since it requires a lot of tokens to represent the simplest amount of information, of course, training time is going to be very high, and these models are also auto-regressive. So for that reason, it's obviously going to increase the training time when you have uh, when you don't expand the tokens. And apart from that, when the training time increases, it's going to obviously increase the cost as well. This can be effective in a few cases like Gemma, uh, Google's Gemma, which was recently released, which already had 256K tokens. So expanding that huge amount of vocabulary, I don't suggest that because it's going to have a lot of other problems in terms of performance as well. So uh, for smaller models like smaller vocabularies like Llama, which only has about 32,000 tokens in its vocabulary, it does make sense to expand it and continue the pre-training. And yeah, and also you can also decide to skip the pre-training phase altogether. And by doing that, I've generally not seen good performance. In fact, the model gets a lot worse, and there is a problem called catastrophic forgetting, which uh, which is more common if you do this direct fine tuning for more than 3 or 4 epochs. Especially if the dataset size is huge and if it doesn't have English instructions in it, you'll see the performance also regress. And yeah, how about the original English capabilities? Because we are adapting Llama for Tamil, we are going to train it on a lot of Tamil data. What about the original capabilities in English? How far does it affect the original knowledge? And to counteract this imbalance, like since the pre-trains didn't have any Tamil, so we continue the pre-training on Tamil only data. This is generally doesn't impact performance by much. Pre-training on a on only on Tamil would also not have a big impact on uh, the performance on English, as far as I've seen if you use LoRa. But if your fine-tuning instructions does not have any English instructions, then that original performance will degrade by quite a bit. So it's important to make sure that there is an equal proportion of English and Tamil samples uh, in your fine tuning. It is optional. If you only want the performance to be good at Tamil, then you can either ignore it. But I've generally seen that when you also include English data set, I mean English instructions along with Tamil, uh, it helps in the model performance. Also in Tamil. And
Abhi, sorry to interrupt. We'll take another 2 minutes to wind this session.
yeah, sure. I'm
Yeah.
almost
Okay.
done with this. The next
Okay.
next slide is.
Fine, Abhi. Fine. Go ahead.
And when we talk about the limitations of this, of course, there is the constrained knowledge base because of the lack of huge amounts of pre-training data, and there is not much that we could do there because already there is not a lot of data on the internet. So yeah, that's one thing. If we create synthetic data sets or data sets that are high quality, that might definitely help. And then ethical concerns. Of course, these models are not aligned, so it can also respond to dangerous instructions, and there is hallucination problems as well. And it struggles with some reasoning and mathematical challenges. Again, this model is not meant for any reasoning or mathematical tasks. It's a general purpose model that we are trying to fine tune, and there is also evaluation hurdles. As I said, there are no proper benchmarks to have evaluated, and there is also a loss due to translation since the alpaca dataset is translated or OpenOka. Most of the samples are translated. Not all the samples are translated. Some of it comes from self-instruct methodology where I use GPT-4 to generate the data. So yeah, most of the data is translated, so that could lead to translation loss, and it cannot respond in colloquial Tamil as well. And yeah, that's it about Tamil LLaMa. I hope you had a clear understanding about how Tamil LLaMa was developed, and you might have already noticed some areas for improvement, which I would encourage you to be part of the community and work with us together to improve it. Yeah, thank you so much. You can reach out to me if you want directly to my email or on LinkedIn.
Yeah, thank you so much, Abhi. அபியோட research paper and models வந்து sort of acting as a benchmark or an inspiration for others to follow along and contribute to the Tamil LLM space. Thank you so much. Abhi, you can reach out in our WhatsApp group, or else you can also reach out to him on his LinkedIn and through email.